Welcome to the .NET Zone. My name is John, and today I'm going to teach you how to build a Python solution to manage network device configurations. Welcome back to the .NET Zone. In this video, I will be displaying how I created a Python framework to configure and manage network device configurations. This video includes topics like source of truth, Jinja templates, and managing network devices with Python. The topics in this video will also fall within the Cisco AutoCore 1.4 exam topic, which is to construct a network automation solution with Python to manage configurations. This video will focus specifically on VLANs. All of the Python scripts that I will be displaying in this video are all using the conlog only connection handler. If you want to learn the differences between the connect handler and conlog only, you can come to this site and read the differences in this article, or watch my previous video on Python basics for network engineers where I briefly explained the difference. All right, let's get straight into the automation. So here's my directory structure. The root of my directory is called python_sot, which stands for source of truth. The first directory is where I'm going to be saving my Jinja templates after they're rendered into the raw config. They're going to be saved in here. This second directory is my inventory. And at the moment, I have a host directory, and inside of the host directory is a file per device in my topology. So I have 2 routers and 2 switches. These YAML files is what I use to define what my configuration is going to look like. So this is my data model for my configuration. This third directory is the inventory loader. Inside, you're going to see a loader.py script. This script's purpose is to parse all of the YAML files inside of my inventory, and then I'm able to pull variables based on certain filters whenever I call with this script. Next is my scripts directory. This is where I'm going to be staging all of the scripts for all of the actions against my network devices. So as you can see, conf meaning I'm going to be configuring, show is I'm executing some kind of show command, and val is scripts that I use to validate certain information. And then my templates directory. This is where I templatize my configuration. At the moment, I have VLANs and interfaces. So the way I render my configuration is I parse my inventory, get variables from my YAML files. I'm able to feed those variables into my Jinja templates, and then I'm able to send them to my network devices. Okay, first, let's go over how the loader works. And I'll briefly go over this. So the loader has 2 classes. I have the class host object and then inventory object. Host is just a different type of information that I'm going to be pulling from my YAML files. And then inventory is how I'm going to be pulling all of those YAML parameters, and then I'm able to parse for specific information that I want to get. So here you're going to see different functions where I'm loading the YAML files, or I'm loading the different hosts. This host calls that load YAML file function as it's iterating through each and passing it to data. So you can see here, the host object, data is where I store the entire YAML content. So if you're going into here, whenever I'm loading these files, I'm pulling all of these parameters into my Python script, so then I can then pass that into different conditions and then be able to use that within my script. Inventory does a couple different things. So here are different functions. So after it's done parsing all of the YAML files in my inventory, so now it creates the inventory. And then I'll show you in a little bit in the scripts of what that variable actually looks like. But these are different functions that I can also use. Get host. This is if I just want to pull the information of one specific host. And then it's only going to return the host name of that device. This second function is if I provide the name of that host, it returns all of the content in the YAML file. So you see here, it returns all YAML content as variables for that specific host. This next one, get host by filter. So these first 2 are host specific, as I'm pulling a single host. This one is saying, hey, I can provide a host name and it'll return that host. I can provide a role and it'll return all of the hosts specific to that role. or tag. So you can see switch one here. I have the role parameter. I have different tags, switch, spine, and then host name. So those three different parameters, I can pass them through, and then it'll return a list of those hosts. And you can see here is grab the host keys. This next function is returning the variables by filter. So the difference between these two is this one's just returning a list of host names. This one's returning the actual variables inside of the YAML files. And this one is just listing all the hosts in my inventory. And then you'll see how that looks like in some of my scripts. Okay, before I get to the scripts, we're gonna go to the templates. So in templates, again, this is where I stage the configuration. So because we're focusing on VLANs, this is my template for item in VLANs, VLAN name. And this goes hand in hand with these variables. Okay, so this block of code is actually parsing this. So it's saying for item in VLANs, and then saying VLAN item dot VLAN, as in we're grabbing VLAN 10, VLAN 998, VLAN 999, and then the name of that VLAN. So item dot name is calling this key, so HR native unused. It's gonna be doing the exact same thing for the second switch. The first script that I'm going to show you is I'm going to render the content of my YAML files into my templates and into the raw config with this script. So what this script is essentially going to do is going to go into the inventory directory, which is, or all my YAML files are here. It's going to go into the templates directory where all of my templates are at. And then it's going to render those together and save the configuration in the generated configs directory. Let's go ahead and run the script. So I've run Python 3, scripts directory, VAL for validate, render. So this is meant to be interactive. This is going to prompt me for what I want to do. So it's saying config generation tool, enter template name. We're going to generate the VLANs template. Then it's saying, what target do you want? We're going to enter switch because all my switches have VLANs. Okay, so it's saying found two matching hosts, switch 2 and switch 1. Processing switch 2. And then here's the name of the file inside of this directory. Same thing for switch 1. So essentially it used the host name of the device it was parsing as the name for the configuration file, saying, hey, we ran 2 tasks, 2 were successful, 0 failed. And then this is the full absolute path of where I saved it in, which is generated configs. Let's go look at the file. If we go to switch 1, this is what it looks like. And if I pull the variables from the inventory file, you're going to see that VLAN 10 is here, name HR, VLAN 998, name native, and same thing. So essentially everything that I have here is now saved in this file based on this VLANs template. If I want to add another VLAN, I can simply go in here and create another entry. We'll do that right now. We'll say we want to make a sales VLAN. Sales is going to be VLAN 20. And we're doing specifically for switch 1. We see the differences for switch 1 and switch 2. Switch 2 already has VLAN 20, which is sales. But if you look at switch 2's, it only has 3 VLANs as well. Does not have VLAN 10. So we're going to create an extra VLAN here. So we're actually going to run this again. Python 3. We're going to render VLAN again. We're going to do this for switch 1 this time. See, found 1 host. Switch 1. Successful. Let's go ahead and look at switch 1's config. And look at that. VLAN 20 is now in our raw configuration. So this is a way where you can define what your config looks like in YAML, and you don't really have to remember any commands. You don't have to go into any devices to type these commands manually. As long as you can create a template like this, the syntax is always going to be accurate as long as the proper information is defined here in YAML. We're actually going to remove this because I don't want to add this. Okay, let's go ahead and close these out. So here we validated that our config is going to look correct. Now we're ready to push our configuration. So our next script, before we push our configuration, we want to see what VLANs are configured on our devices. We're going to run against our switches. It's going to prompt me for my credentials. Found 2 matching hosts. First, it went into switch 2, connection successful. Here are my VLANs. So we don't see VLANs 10, 998, 999 like I defined in my YAML. Same thing for switch 2. We don't see 20 and the other VLANs. Okay, now we're going to push the configuration, which is going to be conf VLANs. Same thing. It's going to prompt me. I'm targeting my switches. Enter my credentials. All right. So this switch is telling us that there are 6 commands that were generated, that we're sending 6 commands to this device that we're connected to, and then it's actually outputting the commands that we have here. So if we compare this to the devices that are in our files here, let's look at switch 2, which we connected to first. So we sent VLAN 20 with the specific name and 998. So essentially, what we had here that we validated was correct is what we sent to our device. And if we also validate switch 1, now this one has VLAN 10, 998, and 999. Okay, so this is a really good way to be able to validate your configuration if you're using templates. And then when you render against your variables files, you're able to actually see what you're going to send. So yes, here it is accurate. We sent what we believed was going to be sent based on the raw config that we rendered. Okay, so now that we push that configuration, we're going to run our show script against our switches, enter our credentials. Now we're going to see if the VLANs are present. Here we go. So now we have VLAN 10, 998, 999 in switch 1, and then VLAN 20, 998, 999 in switch 2. And yeah, that's how you're able to use Python to be able to display configuration, render configuration, and then also send configuration. So we're going to go over what these scripts look like now that you know how they function. So first, let's go over the validation script. And just a quick note, if you're learning Python, you don't have to create every single line of code manually. I highly recommend using some kind of AI like ChatGPT or Copilot. For example, if you're a fan of VS Code, you can have a free version of Copilot, and this is the Copilot like little chat window. Copilot, because it's here within VS Code, it can see the script that you're in, and you can pretty much tell it like, hey, I want you to optimize my code. I want you to change this. How can you do this within this script? And then it'll provide direct input to your script and be able to generate and solve certain problems for you. So this script, it was actually 100% generated by Copilot based on all of the information that I have in my framework. It was able to know where my inventory directory was, my templates, the generate configs directory, and then be able to take all that as input and render a new file. So we're gonna see what this looks like real quick. And then all of the colors, if you're curious, I'm using Colorama. So these are the libraries that I imported. This is how Colorama initializes like the environment. I'm using syspath to essentially determine where my current working directory is when I run my scripts. As you saw, I'm running the Python command from the root of the directory, going into scripts, and then calling the Python script. Here are the variables for the current directories in my framework. create output directory if it doesn't exist. So this is saying, hey, if the generated underscore configs directory doesn't exist, create it. So it's going to verify if it's present every single time. If it's not there, it'll create it and then be able to save a file in there. Here is the inventory variable. And then this is the inventory class that you saw earlier in the loader, and this is how I import the loader. So from inventory loader, which is that directory you saw here, inventory underscore loader, and then dot loader, which is the script, loader.py, and then import inventory. So that's the class object that you saw in the loader script, passing it here. Again, this is just saying I'm going to be parsing everything in the inventory, grabbing all of the contents in the YAML files, passing it to this variable. These are different functions that the render script is going to be using. This one, all it's doing is taking away all the extra white space. If you're familiar using Jinja templates, whenever you initially render something, for example, like this line will be considered white space. So for item in VLANs, same with N4. So when you render this raw config, it's actually, you're going to see VLAN ID, name, 2 spaces, VLAN, name, 2 more spaces, because for item in N4. So this function is just going through each line in the file and taking away the white space. So you're able to see it. If I go back to that, like this, it's all together, right? Instead of like this, it'll literally look like this if you don't take the white space off. And it'll send it to the device like that, the extra white spaces, and it takes extra processing that isn't necessary. Second function is to render the template. These are just different Jinja specific things. This is the environment templates directory. So it's grabbing the template, env.get template, and then it's going to grab the host parameters that's grabbing from YAML. So it's saying, hey, in this template, render against these variables, and then passes it to render config. Then render config has the rendered Jinja template, the way it looks originally. Then it gets passed into the strip white space function, which takes the actual white space off. And then we're able to return that back to the variable. And then save config, which is, it's going to open up a file, which is the hostname.cfg that you're seeing in the generated configs. So switch 1 and switch 2. And then saving it. So it's writing to that file, saving the rendered content. And that's what it's doing. This is the actual like logic. So here's that print statement that you first see. This is asking me for the name of the template. This is asking me what devices I want to target. So the target variable. So this is how I'm able to get different inventories generated depending on my target. So if I do target all, that means I'm targeting every device in my inventory. I'm doing list hosts. So again, this is a function you saw in my loader script. This is just grabbing all the devices. Else, host, get host by filter. So filter meaning if I specified a role, like I specified switch or host name. So this one specifically host name. If not host, then role. So I can specify a target for a single host. I can specify a target for devices with a specific role, or I can say all and it just returns all. Some error handling, if nothing got returned from those variables, we're going to end the script. And then for hostname in host, now we're iterating through our hosts. Get host variables. It's going to get the host name. And then the actual function where it's grabbing the rendered config. So the rendered template function that has all the logic to render the template and the variables. And then this is just some extra stuff saying, hey, out of all these devices that I was able to parse through, was it successful? Did it fail? And then it's able to tell me, the success rate of the automation. Okay, that's for the rendering. Let's look at how I'm able to display the configuration of my VLANs. So up here, this is what I'm importing. I'm using the connection log only. Get pass to be able to pass my passwords in not in plain text, so obfuscated, and then colorama to be able to have all the colors. So quick note, I did use Copilot to be able to optimize the script. So I built all the logic myself, and then I told Copilot, hey, can you add color to all of the statements that I'm printing out? And it literally generated, and I told it using Colorama, and it generated the exact same script that I told it not to change it, except it went to all of the print statements and added color based on the context of that print. So if the print had error, all it did was add 4.red. That's all it did. Like it didn't even change the wording of anything, which is really nice because this is something that just make your script look a little bit prettier, maybe more legible when it prints things out to the terminal. And then you don't really want to do all of that manually. So let's say like depending on how many lines you have here, just tell Copilot, hey, like add some color to my stuff. And it'll know if it's like connection successful, it'll add green. If it's connection error, it'll add it as red. If it's a warning, it'll do yellow. If it's just like normal output, I told it to do blue or cyan. Okay, so some of my functions. So this is what I use to connect to my devices. And I won't explain these in too much detail. If you want to learn what some of these functions are doing, these are the exact same functions I used in my previous video. So if you want to learn these in detail, go to my previous video. I explained each how I connect to the devices, how I disconnect, how to execute each command. Just know that this is a function to connect to my devices, disconnect, and then execute those commands against my devices. So same thing, I define a target. So if I want to do a single host, if I want to do a tag on those hosts or every single host in my inventory, username, so regular input, enter username, and then for my passwords, I use getPass. Loop devices, so this is how I create my hosts variable. So get host by filter, role switch. Again, this is a show VLANs Python script. So I'm going to be running against all of my switches, excuse me, and not my routers. So I will specify a filter here. Again, this is a function inside of my loader script. This is what's helping me get host by filter. This is what's helping me be able to parse this inventory file, all the files in here, and be able to return only what I want to see. So it's acting very similar to how Ansible is specifying some of its targets, except I'm defining the logic myself. So here, based on this logic, it's grabbing all of my switches, some error handling saying, hey, if no hosts were returned, no host found error, it's going to display it in red, and the script. Filter host by target. So here I'm getting the host variables. So for host and hosts, again, that's the host variable. Now I'm iterating through each one, grabbing their variables, and then some error handling. If not variables, error. Here's some of the parameters inside of those files, hostname, role, and tags. If target equals hostname, target, or tag, or all, matching host append. So it's making a new list based on the target condition that I created. So first is grabbing all the switches. But then, let's say in my target, I wanted just one of those switches. I can specify the host name, and then it's saying, hey, it only meets the condition of the host name. Add that host to this object, this list that I created. So not only that host will be in this list, more error handling if not matching host, no host targets, red, exit. And then here's the print statement that tells you how many devices matched based on the logic. So if I target one specific host, it's going to print one host, two hosts found, three hosts, whatever. Now this is the actual logic of our automation. So everything that you saw above is generating our inventory file, being able to filter our inventory file based on the target that I want to execute my automation against. And now we're ready. So we're saying for host in matching hosts, grabbing the variables again, device vars equals inventory dot get host variables. These are parameters that I'm mapping from my YAML file. So let's go open one of those up. So we go to switch one. So we go to the top. So device type So these are the parameters I'm defining to be able to hand that over into NetMiko. So NetMiko needs a device type. So whether it's iOS, NXOS, JuneOS, it needs a device type. So it knows what OS is going to be or CLI is going to be inside of, the host address, the credentials, and the port information. So that's what I'm defining here in variable from my variables files. So device type, so device vars, device type, which you're seeing here, and every file in my inventory is going to have these same parameters. So device type, Cisco iOS. Host address is device vars host. This is the IP address that I'm passing here. And then host name, role, and tags. So the different tags that I have. And then I'm passing these parameters down to NetMiko. So device object, device type, host address, credentials. Cool. Now, this is where I'm passing it to NetMiko. So net connect equals device connect. So I'll show you what this looks like. So net connect calls a conlog only connection handler. It passes that device object that we created for NetMiko. Then some error handling. If it doesn't connect, exit, else. You're seeing here, let's move this over. So host connection successful, prints it in green. If that device has an enable mode, it'll pass that secret, and then it'll return the connection. Back down. So this device, all right, now we're connected into our device. Now we're executing the command against our device. So because we want to look at the VLAN information, we're passing command show VLAN brief to execute commands. Let's look at execute commands. So NetMiko wants us to pass the send underscore command function and the command that we're sending. So netconnect.send command, and then the command show VLAN brief. And then it'll print the output in cyan. Go back down, send this command. This is going to output it, and then, which is just one command, is VLAN for the VLAN, show VLANs, and then it will disconnect. Okay. So that is all of the logic for this script. And let's go over what the configuration looks like. All right. So the configurations look very similar. Like everything's going to be pretty much identical. The only difference is that instead of we're sending a show command, we're sending a configuration command. So from the top, again, a lot of the same libraries. The biggest difference is that we're going to be rendering a Jinja template because that's how we send our configuration. So we're grabbing our variables, we're rendering that against our Jinja templates, and then pushing that config out with NetMiko. So same thing, Colorama, the path, inventory, device connect. This function is slightly different because we're making a change. It's going to do device save and disconnect. So first thing it's going to do, net connect.save config. That's it. And then net connect.disconnect. For execute commands, this is very similar to the other one, except instead of send underscore command, it's send config set. The difference between this, instead of sending one string, we're sending a list. So send config set accepts a list of commands, and then it's able to iterate through those objects and send each one in a loop, which you're seeing here. And I'll come back in a little bit. This is a function to generate the configuration. Again, this is using the exact same method as you saw from our render script. So it's going to do the environment. It's going to grab the templates directory, get the template, and then the name of the template and a variable, which you'll see in a little bit. The render config, so it's saying render the template against the device variables. Here's my rendered config. And remember how there's white space in those in the template originally? This variable is where we strip the white space. So saying we're iterating through each line in render config, splitting it, and we're stripping the white space. So if you see strip, that's where we're removing it. And then we're cleaning up the file and then sending it to the device. We don't want to send any more than we have to. All right, let's read the actual logic. So here's the target that prompts me, where we want to target one host name, tag, or all. Target config. This is hard coded because it's doing specifically for VLANs. Prompted me for my credentials. Same thing that you saw earlier in the show. We get host by filter, switch. We get our host variables. Here's the condition for our target. Okay, here's the actual. So for host and matching hosts, get host variables. Here's our parameters that we create for NetMiko. Here's that device NetMiko object. We're gonna connect into that device. Here is where we generate our config. So config commands, then we call that generate config function. We pass our device variables, our target, and the host name. Then we say if config command. So we have to determine if something was returned. If it's empty, this is gonna fail. Execute commands, pass the connection handler, the actual config commands, and then save and disconnect. And then we can run through different iterations of our targets to just validate how this actually functions. So if we look at switch 1 and switch 2, this one, they both have tag switch. So if I call switch, it targets both of them. So let's go do that real quick. So script, so if I target switch, that's my credentials, 2 matching hosts found. It shows the VLANs of both our switches, switch 1 and switch 2. But what happens if I call tag spine coming from switch 1, enter my credentials, 1 matching host found, switch 1. And because this one doesn't have spawn, this one has leaf. What if I call leaf? So let's go call leaf object, enter my credentials, 1 host found, but this one we're in switch 2. So this is how we're able to use tags to be able to target specific devices. I know I only have 2 devices, but if you have big environments, you have different sites, you can have different tags or different role objects that you can call to be able to execute this automation to the intended target. What if I want to call the host name? Let's say I want to call switch 1. 1 host, switch 1. Let's do switch 2. Host name switch 2. 1 host, switch 2. Let's do the same thing for configuration. Let's say I want to target just my leafs. Right? Switch 2 has that leaf tag. We targeted switch 2, and I send the commands just switch 2. So Python is extremely powerful because you're able to create all of this yourself. You could use something like Ansible that has this framework already pre-built out for you. Or if you want specific use cases that you can get out of Ansible, where you want to be able to code certain conditions for yourself, create your own tags, create your own parameters, you can do that here with Python. Create your own framework, have your own templates, your own scripts, your own source of truth. So here, our source of truth, we're able to define what our config looks like, render that against a template, and then be able to push out these configs however you want. So highly recommend learning Python. It's extremely powerful, and you can continue building on this. You can create tests to test against your network devices. That concludes our Python video. If you enjoyed what you saw, don't forget to like and subscribe and stay tuned for future videos.